In this video, I will go over the homework that follows the lecture 10.1, in which we explore the certain pattern and learn how to do inverse trigonometric substitution. As always, I hope you watched the lecture, and let's go ahead and jump right into the homework. So this is our homework problem. We have an integral from 0 to 0.8 of x squared over square root of 36 minus 4x squared. And the pattern that we're trying to explore here is a squared minus b squared x squared. So you should be able to see that what we have is 6 squared minus 2 squared x squared. So if you set a equals 6 and b equals 2, then you'll get the idea for the right substitution, which is x is equal to a over b squared, I think. So a over b is sine theta. So in our case, it will be 6 over 2 sine theta, which is 3 sine theta. So that means that sine theta is equal to x over 3, and theta will be equal to arc sine of x over 3 if x is within certain interval. And why does the substitution work? It's because if you now just substitute everything in, your x squared will become 9 sine squared theta, and 36 minus 4x squared will now become 36 minus 36 sine squared theta, which is if you factor out 36 and use the Pythagorean identity, which is now becomes 36 of cosine squared theta, and if you also have radical in here, then all that, when theta is in a certain interval, all that becomes 6 cosine theta. Now, because this is a definite integral, we need to change the limits of integration. And to do that, we're going to use this formula right here. When x is 0, arc sine of 0 is 0. And when x is 0.8, we don't know what arc sine of 0.8 over 3 is, so we'll just write it as 0.8 over 3. It's 8/10, so it's 4/5, so it's arc sine of 4/15. And now we're ready to implement this substitution. So our new integral is going to be an integral from 0 to arc sine of 4/15. And inside of the integral, we're going to have x squared, which is 9 sine squared theta, divided by 6 cosine theta. And I forgot dx over here. And dx is, and that's why I forgot dx. Dx is going to be simply squeeze dx in here. Dx will be just 3 cosine theta d theta. So here goes 3 cosine theta d theta. Simplifying everything and cleaning up the integral gives us this. The integral of sine squared theta d theta, by now it's considered one of the simple ones. So to find it, you can check out this, either you can do it by hand following the approach discussed in this lecture, or you can just use this as a fact. So we have 9/2, and integral of sine squared theta is going to be 1/2 of theta minus 1/4 of sine 2 theta, and we valued it from 0 to arc sine of 4/15. And the last step is to apply the fundamental theorem of calculus. And you can do this by hand. I mean, when I say by hand, I mean like using a calculator, or you can use a Desmos, for example, and I actually have it typed over here. Let's see. You can just type this expression up. So we have 9/2, 1/2 arc sine of 4/15 minus 1/4 of sine of 2 times arc sine of 4/15. And it seems like that's the answer. If you want to check your work, and again, this is not a way to solve an integral, but if you want to check your work, you can just plug this in. And hopefully it's the same, which it is. So the final answer is 0.029. Let's write this here. 0.02908. We have to round to 4 decimals, so 0.0291. I don't necessarily you kind of forced to use calculator here anyway, so I don't think it's necessary to use a triangle here, but let's see. Here's another problem. Very similar to this, to the original one, but this time we have indefinite integral. So what you do want to notice here is, just like before, you want to take advantage of this pattern. So you have to notice that 1225 it's 35 squared, and 49 is 7 squared. So the following substitution should take care of this pattern. X will be equal to 35/7 sine theta. So 35/7 is 5. And dx will be equal to 5 25 cosine theta d theta. X squared will be 25 sine squared theta. So 1225 minus 49x squared square root will be 25 cosine theta. And now we're gonna, because it's an indefinite integral, we're going to use the reference triangle. So we're going to use the fact that sine of theta is x over 5, and we'll draw a reference triangle right over here. So sine is opposite over hypotenuse, and if I label this x and this 5, then by Pythagorean theorem the adjacent side will be 25 minus x squared. And after all this prep, now we're ready to do the integral. The integral will now become in terms of theta, so we have 25 sine squared of theta divided by 25 cosine theta times we have dx now, so it's going to be 5. Actually, hold on, the 49. Yeah, let's just continue. 5 cosine theta d theta. Why do I say 25? I think this is 35 right here, because this number should be matching this number. So this will be 35. Yeah, something wasn't adding up here. So now it's right. Okay, now we going to reduce everything we can. So this is 7. So we have 25 over 7 integral of sine squared theta d theta. And just like before, just like in the previous problem, we are expected to know that integral. So I'm just gonna look it up here. So integral of sine squared is 1/2 of theta minus 1/4 of sine of 2 theta, but having sine of 2 theta as a double angle function doesn't help us, so I'm going to write it as 1/4, but instead of sine of 2 theta, I'm going to write it as 2 sine theta cosine theta using the trig identity. And the reason I've done that is because, remember, we need to go back to x. And to go back to x means we need to express everything in terms of theta back in terms of x. So instead of theta, we now have to write arc sine of x over 5. Now, instead of sine of theta, we're going to write x over 5. But instead of cosine of theta, this is when we're going to be using this reference triangle, and we're going to take in the adjacent side and dividing it by the hypotenuse. And now we got the final answer. So let's type it up. It's going to be 25 over 7, 1/2 half arc sine of x over 5 minus, here we have x, we have x square root of 25 minus x squared over 50 plus c. And of course we can distribute this 25 over 7, which will probably make it look a little nicer, but it's okay if we don't. So again, remember, for indefinite integrals, you most likely will need the reference triangle. For definite integrals, you will need to change the limits of integration. So most likely you will not need the reference triangle. Okay. Alright, so here we have an integral of just the square root of 2304 minus 36x squared dx. What you want to notice is that square root of, I guess 2304 is the perfect square of 48. So we have 48 squared minus 6 squared x squared. So I get the idea for substitution here. My substitution should be x is equal to 48 over 6 sine theta, which makes it 8 sine theta, which means that dx is 8 cosine theta d theta. This is indefinite integral, so I'm going to be drawing the reference triangle there. So let me make some room. My theta will be, so here's the true fact, right? So sine of theta will be equal to x over 8, which is opposite over hypotenuse. So my reference triangle will look like this. Opposite, hypotenuse, adjacent. So this is 8, this is x, and this will be square root of 64 minus x squared. But if I ever need theta, theta will be equal to arc sine of x over 8. And now the reason we're doing this substitution is because square root of 2304 minus 36 x squared will simply become now a 48 cosine theta. And this was all the prep. This was the idea. And now we can write this integral as 48 cosine of theta times dx, which is 8 cosine of theta d theta. We take out 48 times 8, which is 384, I guess. Integral of cosine squared theta d theta. And let me just check real quick. 48 times 8 is 384, okay? And to find the integral of cosine of squared, we are going to use the method described in one of the previous lectures, when we learned how to integrate the powers of cosine. But integral of cosine of squared, it's always going to be the same. So we can just refer to this as the common knowledge. And integral of cosine squared is 1/2 of theta plus 1/4 of sine of 2 theta, but instead of sine of 2 theta, I'll be writing 2 sine theta cosine theta using the double angle identity. So this is the answer in terms of theta, but remember, we don't need it in terms of theta, we need it in terms of x. So I'm going to pull out this 1/2, so it's going to be 192, and here I have theta, which is arc sine of x over 8, plus sine of theta, which is x over 8, times cosine of theta, which is the adjacent side of that reference triangle, divided by the hypotenuse. And that will be the final answer. All right, problem number 4. We did a problem like this earlier, so this one should go a little smoother, as we don't have to think too hard about the steps. We're just going to run through them. But the idea is, again, we notice this pattern. We notice that 144 is 12 squared, 9 is 3 squared. So we're going to use the following substitution. X will be equal to 12 over 3 sine theta, which is 4 sine theta. Therefore, dx will be equal to 4 cosine theta d theta, and theta will be equal to arc sine of x over 4. So because it's a definite integral, we're going to be changing the limits of integration. So when x is 0, arc sine of 0 is just 0. But when x is 0.2, arc sine of 0.2 over 4 is going to be arc sine of 0.05. And the reason why we're doing this substitution, it's because the x squared will be equal to 16 sine squared theta, so that square root of 144 minus 9x squared will simply be 12 cosine theta, assuming that theta is within a certain range of values. And now we can plug everything in and continue with this solution. So we have an integral from 0 to arc sine of 0.05. X squared is 16 sine squared theta divided by 12 cosine theta, and dx is 4 cosine theta d theta. Simplify. And we have a new, much simpler integral. We have 16/3 integral of sine squared theta d theta from 0 to arc sine of 0.05. We definitely know the antiderivative of sine squared. It's x over 2 plus 1/4 of sine of 2x. I already memorized it by using it on this homework, but just to double check, here it is. Ooh, that would be a terrible mistake. It's minus, so I didn't memorize it, I guess, well enough. And since we have a definite integral, we don't do plus c. We use the fundamental theorem of calculus, so we evaluate it at the boundaries. And in our case, that just means we plug in arc sine of 0.05 and at 0 everything is 0, so it's just minus 0 over here. And we have to compute this using a calculator. I'll use Desmos as my calculator, and 16/3 arc sine of 0.05 divided by 2 minus sine of 2 times arc sine of 0.05 divided by 4. And the answer is 0.002. And we finished this homework. So if you have any questions about how to use this pattern, please feel free to reach out.